Hello students, welcome to Eduxcite classes. In today's session, we will discuss paper 1 MCQ of topic 2 mechanics. Okay, so it's a small request to all my students. Please solve this worksheet, and the link of this worksheet in a PDF format is available in the link given in the description. Okay, so please attempt all the questions and then you can cross verify your answers and then you can come back to this video. Okay, so starting with the very first question, which one of the following is a correct definition of displacement? Now we know that displacement is nothing but the shortest path between your initial position and your final position, or you can say a distance traveled in a given direction. So it's a direct answer. Option D is the right answer. Sorry, option C, distance from a fixed point in a given direction. Now question number 2, the minute hand of a clock hung on a vertical wall has a length L. Now this is a length L and this is the minute hand. This is the point P. So we have to find out the displacement and the distance moved by the end P of the minute hand during the 30 minutes. So we know that after 30 minutes this will be at this position. Okay, so the point P, how much has traveled? Okay, so the end P, so you can see the point P has traveled like this, which is forming a semicircle. So this will be the path traveled by the point P, which is the distance. And if we want to find out the displacement, this is my initial position, this is my final position. So from this point till this point you can find out this is the displacement. So displacement is 2L vertically downwards and distance is the semicircle, which is the half of the circumference, which is pi r. R is your L. Okay, so pi L. So the option for this is A, 2L vertically downwards and pi L is the distance. Question number 3, which one of the following correctly defines average velocity and average acceleration of the particle? Okay, if a particle is moving from point P to point Q in a time interval of t, so we know that displacement is nothing but, average velocity is displacement upon time, final minus initial upon time, and the average acceleration is the change in velocity from Q to P upon time. So direct option B. A ball is thrown vertically upward from the ground. The graph shows the variation with time t of the vertical displacement d of the ball. Okay, which of the following gives the final displacement after time t and the average speed between the time t from 0 second to t equals to capital T? Now if you see, it is thrown vertically upward. So if a ball is thrown vertically upward, it will come back to the same position. So the displacement is nothing but the 0. But if we talk about the speed, so if speed is what? The distance, average distance upon time taken. So average distance is what? It reaches to a maximum height of capital D. So the average distance is twice of D, because once it is moving upward, once it is moving downward. So 2D upon time, T is the average speed. So looking at the option B is the right answer. Okay. Now question number 5, the graph below shows the variation of time t of the displacement s of an object moving along a straight line. So this is moving along a straight line. Don't get into the confusion of this curve of a graph. It is moving on a straight line and the graph shows the displacement versus time. Which best estimate of this instantaneous speed of the object at 2 seconds? Now we have to find out the instantaneous speed at 2 seconds. So you can say at 2 seconds, what is the at 2 seconds, you can see it is the maximum point of this curve, and at this position the gradient is 0, or you can say the ds by dt, or in terms of delta s over delta t is 0, because at this particular instant of time, if I zoom it out, zoom in, so you can see this is a very straight line. Okay, so there is no change in the displacement with respect to time at this small interval of time. So I can say here one thing, that this is the speed which is 0, or you can say at this position the direction is changing, because once the direction the displacement is increasing and then the displacement is decreasing, it means the direction is changing, and whenever there is a change in the direction at that particular instant, the speed will always be 0. Okay, now there are 4 cars W, X, Y and Z which are moving on a straight road. The graph below shows the variation of time t of the distance s for each car from a fixed point. Okay, which car has the greatest speed? Again, it is a displacement versus distance versus time graph. So the slope, okay, the slope of distance versus time gives you what? Gives us the speed. So the maximum, we are not taking the positive or negative, we just take the magnitude of the slope. So there is no change, so the x is having speed 0. Now for the short interval of time t, at this position you can see the maximum change in this distance, or the maximum distance traveled is by w in the shortest time period. So you can say the w is having the maximum or the greatest speed, which is option A. Okay, now question number you can check for the other gradients also. Y and Z are also, so you can say if I want to give an order, so w is having maximum, then in the y you can say is the second, then z, and the minimum is your x. So this will be the order of the speed of the 4 cars. The diagram below shows the variation with time t of the velocity of an object. The area between the line of the graph and the time axis. It's a direct question. You can see that the area of velocity versus time graph, okay, velocity versus time graph gives us the displacement. Always remember, it gives us the displacement of the object. Now question number 8, an object has an initial speed u, acceleration is a, after traveling a distance s, the final speed is v. The equation, we know this, the equation of motion. So for this equation, guys, you have to be very careful while using these equation of motions, that these equations are only and only applicable when your acceleration is constant. And when I say acceleration is constant, it means the magnitude as well as, because it's a vector quantity, as well as direction, both are supposed to be the same. If any one thing is changing, then we cannot use this equation, or if direction is changing, then you can have to use it for twice, one for the one direction and other for the second direction. So A has a constant direction, and constant magnitude. Yeah, option C is the right answer. Okay, all these equation, it is not only about this, that is v equals to u plus at, s equals to ut plus half at square. These all equations in this acceleration has to be constant. Okay, now question number 9, a stone x and is thrown vertically upward with speed v from the top of a building, and at the same time a second stone y is thrown vertically downward with the speed v as shown. Air resistance is negligible. Which one of the following statement is true about the speed with which the stone hit the ground at the base of the building? Now this is very common, okay, and question. So if x is moving vertically upward, it will go like this and it will come at this position at the same level. Okay, if air resistance is negligible, it will have the same speed v now in the downward direction. So it doesn't matter that x is moving upward or y is moving downward. If they are at the same level, one is thrown vertically upward, one is thrown vertically downward, when this will come back, this will also have the same speed. Now the height is the same, acceleration due to gravity is also same, air resistance is negligible, and these both the stones are of the same, so they will hit the ground at the same time, no sorry, not same times, with the same speed. Okay, So the speed of stone x is equal to the speed of stone y, which is the option C. Or if you want to prove it, I can also prove. Let us say the height of the building is h, okay, and so let us say the velocity is v dash. So v dash is equals to v square plus 2a. A is your g and h is your height, okay. So taking downward direction as positive, so v is also positive because it is in downward direction, g is also positive because it is in downward direction, and particles are moving from the building in the downward, so h is also positive. So for both the cases, for x as well as y, the v dash will be the same. So the speed of the stone x is equal to the speed of the stone y. Now question number 10, a body starting from rest, okay, so the value u is given to you as 0 along a straight line under the action of a constant force. After traveling a distance d, the speed of the body is v, okay. Now we have to find out the speed of the body when it is traveled at a distance d by 2. Let us say this is the point at a distance d by 2. We have to find out the speed. What will be the speed? Let us say v dash, okay, and this is the speed at a distance d if a constant force. So let me make an equation, and initial position the speed is 0. So v square will be what? U square plus 2as. We know this equation. So let us say at time d, at a distance d, v is the v square, u is 0 plus 2, let us say a into s is your d, okay. So a can be written as v square by 2d, okay. So this is the acceleration, and it is given that it is a constant force, so the acceleration is also constant, okay. Now for the second case at d by 2, I am again using the same equation, v dash square, u is 0 plus 2a, we can write as v square by 2d into, now the distance is what? Distance is d by 2. Now solving this, you will get v dash square is equals to v by root 2, okay, that is v dash only. So simple mathematics you have to apply, you will get v by root 2, okay. So this is the answer for question number 10. Okay, now question number 11, the graph shows the variation with time t of the velocity v of an object. Now you can see here the velocity is decreasing and then it is increasing. Which of the following graph best represent the variation of time t of the acceleration a of the object? Now in such type of question, guys, you have to check the options, okay. Now first try to eliminate the options. Now here you can see the acceleration is constant. No, if the acceleration is constant, it has a straight line for velocity versus time graph like this, but this is not the case. So option B is not the right answer. Similarly, option D is also not option D says that at this point the acceleration is maximum, but acceleration is 0 at this point, so this is also incorrect. B and D are eliminated. Now we have to select for option A and C. Now if you see, the velocity is decreasing, so acceleration has to be in negative, so this is also incorrect. So only option is A. Now how will you check it is the best representation? At this point the acceleration is 0, and at this point before this is negative, and after this is positive. So this is showing the positive acceleration, this is showing the negative acceleration, because acceleration is decreasing. So option A is the right answer, okay. Now question number 12, the graph shows the variation with time t of the acceleration. Again, this is the acceleration versus time graph. The object is at rest at t equals to 0. Which of the following is the velocity is the best object at time t equals to 6 seconds? So at t equals to 6 seconds, you see this is the acceleration, which is, I think this is 12, this is 11, 12, 13, this is 14, okay. So this is at this point, which is 12, okay. So acceleration at 6 is 12. Now we have to find out the velocity of the object at time t. Now we know that this area under the curve of acceleration versus time graph, this shaded part, okay, this shaded triangle, the area of this shaded triangle gives me what? This gives me the change in the velocity, okay, and it is already given that the initial velocity is 0. So I can write acceleration is delta v over time, and delta v is final minus initial into a into time. A into time is the area under the curve, which is half base is 6 into 12. So this is 6. So and u is 0, so v minus 0 is v only. 6 into 6 is 36. So this is 36 meter per second. Okay, always remember this area is the change in velocity, not the velocity, change in velocity. Now question number 13, again the graph below shows the variation with time t acceleration. So acceleration versus time, it is at rest. The shaded area represent now in this question the speed of the spaceship at time t equals to, because again the spaceship is at rest, so v is equals to a into t, which is the area, so it will give you the speed at time t equals to capital T. Now question number 14, a raindrop falling through air reaches a terminal velocity. Now for terminal velocity we know this, at terminal velocity the resultant force is equals to 0. So the at terminal velocity the frictional force of the raindrop, so if frictional force is, this is my raindrop, frictional force is like this, so this will be the weight, so it will be equal to the, so or you can draw like equal magnitude, so weight will be equal to the friction in this case, which is option D is the right answer. Okay, now question number 15, again the steel sphere is dropped from rest in a oil. So you can see that, let us say this is a oil filled in a long container. Okay, now it is a steel sphere, okay, it is being dropped in this container. So we know that if a steel ball like this, if this is dropped, so it will go and it will achieve a terminal velocity due to the viscosity of the liquid. So speed will continuously go and increasing and it will reach a constant velocity. This is known as terminal velocity. Rest all graph are incorrect. Option A is the right answer. Question number 16, the ball is thrown horizontally from the top of a cliff. Air resistance is negligible. Which of the following diagram best represent the subsequent path of the ball? Now if you see, it will move like this, it can't be moved like this, so option A is the right answer. It's horizontal, so the weight will act in the downward direction and it will move like this. Now question number 17, a stone is thrown at an angle to the horizontal. The horizontal component of the initial velocity of the stone determines the value of. Now if you see that in this type of projectile, the horizontal velocity only determines the range. So range only. Question number 17, answer is A. A stone is projected horizontally from the top of a cliff, neglecting air resistance. Which one of the following correctly describe what happens to the horizontal component and the vertical? We know that horizontal component is constant, it doesn't change, and vertical component is it decreases and then it comes again increases as per the motion. So vertical component increases because initially it is 0 vertical and then it decreases again. So constant and increases, option D. Question number 19, the ball rolls off a horizontal table with velocity v. It lands on the ground at time t, later at a distance d from the foot of the table. Air resistance, a second heavier ball. Okay, now heavier ball means only mass is changing, velocity is same. Which of the following is correct for the heavier ball? Now please guys make this very clear that there is no effect of change in mass in free fall or projectile. There is no role of the mass of an object, it is independent. So time and distance both will be the same. Okay. Question number 20. A projectile is fired from the ground at time t. It lands back on the ground at time t. Okay. Which of the following sketch best shows the variation with time t of vertical and horizontal? Horizontal again is constant and vertical is decreasing. Okay. And then it increases also. So the option B is the right answer. Rest all are incorrect. VH is constant. So these are incorrect. And here it is continuously decreasing, but it is from the ground it is, so it will be like this. So first it will increase and after this point it will decrease. So this is the right option. Question number 21. Which of the following statement is correct? So you can see two identical spheres x and y are released at the same time from the same height above the horizontal ground. The sphere x is vertically from rest, sphere y is projected horizontally. For this also the vertical speed is 0. Okay. So which of the following is statement? Sphere x hits the ground before and y? No, this is not possible. Sphere y hits the ground before? No. Hits at the same time because horizontal motion does not affect the vertical motion. Yes, this is the right option. Question number 22. The diagram below shows the now this is again a student get confused. The resultant force on the point x. So here when the object is in under the motion, which force is acting if there is no air resistance? The only force which acts is the weight which is acting in the downward, option D. There is no other forces acting. A particle is projected horizontally with speed v from a height h. It's land on a horizontal distance r from the point of launch. A second particle is projected horizontally from the same height with speed 2v, neglecting air resistance the horizontal distance. Now for the first case, okay, so I can write the range. Okay, range will be nothing but the vertical speed. The particle is horizontal with speed v. So I can write like this. The horizontal distance will be what? So h is equals to ut. Ut is 0 half g t square. H is equals to, so time is equals to 2h by g under root. Okay, so time is this. So it doesn't depend upon the velocity. It is only depending upon the height. So the same time it will take for the next. Okay, so I can write v as this speed v square or v equals to u plus at, or I have to find out r. So v square equals to u square is 0 plus 2a h. Okay, so v no, I have to use the, now r is what? Speed, horizontal speed is equals to distance upon time. Distance is r upon t. So r is what? R is speed into t. So v into t is what? 2h by g. Okay. So similarly, for if the speed is 2v, okay, so time has to be the same. There will be no change in the time. Okay. So 2v is equals to r by t, r dash. So r dash will be 2v times of t, and t is again the same 2h by g. So it will be, or I can write this as r equals to vt. So this vt is r, so it will be 2r, which is option C. So always remember, time is independent of the speed. It depends only on the height from which it is being dropped. Now question number 24. Vertical component of the velocity and the acceleration of the projectile when it has maximum height. So when at a maximum height, we know that the velocity is 0 but the acceleration is g only. So velocity is 0, acceleration is z. 25. This is a good question. A board is moving in the direction with a speed 5 meter per second as measured by Nico, who is at rest. So this is person is at rest. Okay, it is not moving. Aziz walks along the deck. he is moving in this direction with 2 meter per second measured relative to the boat. If the velocity is measured as positive in the direction, this is the positive direction, the velocity of Nico relative to Aziz. Now look here, now this is plus 5, this is minus 2, because this is Aziz is moving with minus 2. So the relative speed of Aziz with respect to boat, okay, is what? I repeat, the relative speed of Aziz with respect to boat is plus 3. Now Aziz is moving plus 3, overall Aziz is moving plus 3. So for Aziz, relative to Aziz, the Nico is moving in this direction with 3. So in this direction it will be minus 3. So option is minus 3 meter per second. I repeat, first what I have done is I have find out the speed of Aziz with respect to the boat. So plus 5 boat is moving, minus 2 Aziz is moving. So the relative speed of Aziz with respect to boat is plus 3 meter per second. It means it is moving in this direction. So if the Aziz is moving in this direction with respect to boat plus 3, so the person who is standing on the shore, for that Aziz, the Nico will be like it is moving in this direction with the same speed in the opposite direction, which is minus 3 meter per second. Okay. Now question number 6 again, the bird is moving 4 meter per second in the north and the car is moving in east in the 10 meter per second. Which one of the following vector represent the velocity of the bird relative to the person in the car? So it is nothing but VB minus VP. P means car or a person, or I can write VB plus of minus VP. So just the vector thing that we have done, you can see in the topic 1 video, the link is given in the description. So VB is like this, and VP, that is the opposite. So the car is moving like this. Okay, so you can join the heads, it will be like this. So option B is the right answer for question number 26. Now question number 27, an object is moving at a constant velocity. Which of the following quantities must have zero magnitude? Constant velocity means what? The resultant force or the force acting on the object is 0. Resultant force is 0. It means option D. Now question number 28, a horse pulls a boat along a canal at a constant speed. It means again the resultant force has to be equals to 0, and these two forces are acting, which are the drag force of the on the boat on the either side. Okay, so which one of the following best represent the free body diagram for the boat? Now if you look at this, just check which of the following can give you a resultant force of 0. So if you see here, using the vector diagram, this will be like this. So this will not give you the answer. Again, the resultant of L and P will be like this. They are also not equals to 0. L and P is like this. This is also not giving you 0. And the best representation, I think, is just the opposite, this. So B, because these two forces will get cancelled out and it will give you a resultant force of equals to 0 for the question number 28, because it is moving at a constant speed. Okay, so B is the right answer. Question number 29, three forces F1, F2, F3 act on a point and it is in equilibrium. Now again, the equilibrium means the resultant force is equals to 0. So the resultant of F1 and F2 must be equal to F3. So resultant of F1 and F2 is equals to F3, which is 6 Newton, option C. Very easy question. Okay, now which is of the following expression gives the force per unit extension, that is the spring constant? We know that F is equals to Kx. So K is nothing but the change in force over change in the extension. So from L1 to L2, change in the force is F2 minus F1 upon L2 minus L1, which is option D. Okay, very easy. Question number 31, a block of mass M is pulled along a horizontal frictionless surface of a force of magnitude F as shown. Okay, so we know that we have to resolve these forces. So this is the theta, so this will be F cos theta. Always remember the component along the angle is the cos component, and 90 degree to the cos will be your sine component. So this is F sine theta. So the magnitude of the acceleration in the horizontal direction, if this is moving in this direction, so always remember resultant force is equals to driving force minus resistive force. Okay, so there is no resistive force, this is equals to 0. So resultant force is mass into acceleration, driving force is nothing but the force in the direction of the motion, which is F sine theta. So the acceleration will be F sine theta divided by m, which is option B. And the last question for the day, a trolley of mass 1.5 kg is pulled along a horizontal table by a force of 5 Newton. Okay, so you can see the diagram. The friction force is 0. Again the same, ma equals to driving force minus resistive force. Okay, so acceleration will be driving force is 5 Newton, friction is 0.5 divided by 1.5. So if you solve this, you will get the answer 5 minus 4.5 divided by 1.5, which is 3 meter per second square, option C. So I hope you like this video. Even you can download the PDF of this worksheet as well as the marking scheme. The link is given in the description. Please comment in case you didn't get any of the questions. I have tried my level best. So keep learning, and in the next video we will solve the other 30 questions of the same topic too in my part 2 of this video. Okay, thank you, keep learning.